Robotics and automation teams. Always my favorite. And we're going to start off today with the hard work of one-shot automation. They're here, they're going to explain what they're going to do, and then we'll rotate around, we'll do 3 formal presentations. We'll see if there's time to go for more, but for now we'll do one with one shot, then we'll go over to SIP automation with the cupcakes. And then we'll finish off with a presentation by Team Up for Team Under Pressure. And well, I hope you enjoy the show. I'm not going to talk anymore. They've heard me enough. So I'm going to turn you over first to Matt Leslie, who's the team captain for One Shot Automation, and let him introduce his team and describe what they've done to get where they are.
Thank you, John. Hi, I am Matt Leslie. This is our project, and we are called One Shot Automation. We're making tea light holders, and I'm going to pass it off to Laszlo. He's cell number 1, which is punching.
Thank you, Matt.
My name's Laszlo. I was in charge of the first cell, which was blanking the actual blank to draw the aluminum tea light holder. First, what happens is we put an aluminum roll inside of that housing. Alright, I can't really be in front of myself, but we have an aluminum roll inside of that housing, and that aluminum roll is fed through rollers to keep it tight in between the base plate of the pressure of the press and the pressure plate of the press, and it is bolted to the scrap roller. So as the scrap roller spins, it reels the aluminum roll through. When the aluminum roll is in position, told by the sensors, originally told by the sensors, it's in position. The cylinder will extend, causing the pressure plate to sandwich the material. Causing the pressure plate to sandwich the material between the pressure plate and the base plate, and then the ram will come through and punch out this blank. Something like this. That blank will fall onto that roller, and it will be in pickup position for the robot. Just a little bit about the cell, I guess. There's a huge truss on the top to take the force, because there's 4,000 pounds of force to punch this. So you have 4,000 pounds going down, so you have 4,000 pounds reacting, right? So you need to take that. And yeah, that's pretty much it about the technical stuff. I guess I'll pass it on to Matt, which is the next one. Oh yeah. So again, I'm Matt. My partner was Mercedes. We were in charge of punching out from Laszlo's cell tea light holder that looks very similar to this. The robot drops it off on the die block, which is in the back half. It's very difficult to see from back there, but gets pulled in. A top plate comes down to hold pressure, and the ram head comes through and punches out a tea light holder that looks like this. It then moves on to cell number 3, which is the Cognex vision system, which we were also in charge of. So as you can see up on the screen here, it's just showing a die block, and if you throw a Mercedes, you throw this in there, and if she triggers it, then you can see that now it's passed because there's not a hole in the bottom. But if you were to put in one that has a crack, say like that one she's holding, and it was triggered again, it would show up, oh, apparently that passes too. So. There you go. That probably shouldn't happen, but yeah, that should fail. We have to do a little bit of tweaking on that, and I'll pass it off to the next station, Aaron.
Hi, I'm Aaron Fisher. This is cell 3, where the shaping station. I have Jonathan Orban and other Matt Leslie with me. Basically, our job was to, initially for the shot glass, we were going to flare the lift and hole saw it to the proper shape and then hand it off to the next station. We switched it around a bit, and John's going to talk about our linear positioning.
So we'll begin by speaking about our Bosch Rexrock, which is our linear positioner. It runs the whole length of the cell. Its purpose is to move the die block to each of the 3 substations, and as well as locating holders. Unfortunately, we were unable to obtain the proper hardware and software for the Siemens encoder that we have. So instead, we used taper positioners at each of the 3 substations, as well as soft stops at the ends of the linear positioner.
Great. I'm the other Matt Leslie. I'm going to talk about the hydraulic press. So that hydraulic press has the eye on the end of it that's going to punch 3 letters around the lip of the cup. So it'll punch OSA and 90-degree intervals all around the lip. And I'm going to end it up there.
The second substation is the air reamer. We have a hole saw, and on the inside of the hole saw, you can't really see it. It has a spring-loaded roller ball, so it holds the cup down. We have vacuum inner die block that also holds the cup down, so that when the hole saw comes in to shape it to size, it doesn't kick in or stick to the hole saw. The black and blue thing sticking out the side of it is a cold air gun. So when your hole saw comes down, you have aluminum particles in there, and we want to blow it out and vent it. And for the final substation, it's just a turnover. It's a fairly complicated one, but the die block has to come in. It hits our soft stops to locate it. The rotary actuator will flip, grab the cup out of the die block. Then our horizontal gantry will come over, grab it from it, and hand it off to the next station, which would be Andrew Putt.
Thank you. We took care of painting and cleaning. Originally we were supposed to use a type of lubricant on the shot glasses, so we wanted to remove that before moving on to any kind of further processes, because first off, the paint won't stick to lubricant, and nobody wants to take a shot out of a dirty shot glass, so we wanted to get rid of all that stuff. And we also wanted to create a bit of variety in our products, so we decided to have a paint cell as well, which would we had initially thought we'd do 2 coats, but we're having a lot of trouble getting one really nice coat, so we're getting a really thick coat, and then we would then pass it on to the laser. But a little bit more on the robotics behind this cell is Adam White.
Hi, I'm Adam White. I was in charge of getting the robots set up for our station. Basically, the robot's going to pick it up from the station, load it into a fixture that will wash the T-can holder, sorry. And then after that's done cycling, the robot will then load it into the painting fixture, where the actuator will extend into the paint box, and it will cycle a paint job. And then after that's done, it will retract out, where the robot will then pick it up and place it into the laser cell. Initially, we were going to run all this off the painting and the wash bay off a PLC, but due to some changes late in the game, we rewired it this entire station to be controlled from the robot, which ended up just giving us a little bit of a longer cycle time. Our friend Curtis Just will talk a little bit about the programming behind this.
All right, hi everyone, I'm Curtis Just. So I was basically in charge of the programming of the robot. We only use a robot, so a robot only goes sequential, 1 step at a time. So basically it was all just 1 steps. So the robot would go in, pick up the part from the previous station, put it into the wash bay, and then it would go retract into the wash bay and get it sprayed by water, come back out, go into paint, and then get painted, of course, and then we'd give it to the laser station, which is the edge.
Afternoon, ladies and gentlemen. My name is Nathan Hilliker. Evan Vaznik here, handling the laser cell. If you'll direct your attention to the silver box in the middle of the cell. This first robot here will actually unload when the drawer opens, take out the first cup. It will hold it up for the second robot to grab, and then it brings over to Bryce's station. And this first robot will then again load the laser cell for the next part to be etched. And Evan's going to break down a little bit of the programming and software for the cell.
Hey everybody, I'm Evan Vaznik.
So basically, this is our first introduction to anything lasers. We've never worked with any kind of programming before, so that was our biggest hurdle for this cell, was just understanding how to program them. It took us a while, but we actually integrated it with a PLC. So as we'll hopefully be able to show you later on, we have an HMI set up over in the right-hand corner of our cell with several different images. We hope that if it works right, you'll be able to pick whatever image you want. We'll close up the laser, it'll etch, and it'll be able to have a custom, or out of a list, a set of just images that you'll be able to have. With my cell, I was also in charge of the PLCs for the entire cell. We're running 2 Schneider M258s and 1 Rockwell Slick 500. The biggest thing is, we had no experience with the Schneiders before, so there was a big learning curve, but after we overcame that, it was actually pretty good, really good to program with. And the Slick 500s, we all love algebra here in the RNA program, so it was good to start off with. However, it got really odd because we actually have 3 different power supplies in there right now. We have 120 volts powering the CPU. We have an external 24-volt supply powering most of the input-output cards in there. And since my laser is actually generating its own energy, we actually have to put the laser's power source in there as well. So that got extremely complicated for us, but we didn't do too bad. So then after that's all said and done, like my partner Nathan said, the robot will pick it up out of the cell and put it into the next station, which is the packaging.
Good day, everyone. In front of you, you see our packaging cell. The purpose of our packaging cell is to create a visually appealing product for the user and hopefully enjoyer, and also to protect it in transport. It's a highly mechanized cell. We use very little robotics in it, and there's dozens and dozens of actuators, cylinders, sensors, both pneumatic and electric, varying different levels of electricity. But we try to make the cell unique by using the blade to do 2 cuts at once. The length of the cut along with the bevel along the side, which we were going to have a logo burned upon the side of it. It's going to look great, but due to time constraints, we had to switch to a stamp, which just used ink to seep into the wood. We use a Dremel tool with a lot of blades on top to ground 2 grooves in the top, one for the tea light holder, the other for the tea light. Again, to help it set itself during transport. If complications didn't arise with our shrink wrap supplier, we would have today been able to show you the shrinking of the shrink wrap and how it really holds the product firmly. But instead, we'll just have to show you as it sits in the block itself. And that right now is the extent of our cell. Unfortunately, the shrink wrap oven does cover up a lot of the interesting aspects of the cell. So we have at the very far end of the cell, we have a webcam that will display everything behind the oven. I'll pass it back to Matt now.
Thank you, Bryce. Okay, so we're going to start and try and run through everything to give you guys a decent show. So we're going to start with Basil's cell.